Hello everyone, welcome again to VFD Hacks by Rohit. So today I'm going to make a video in which I'll be showing on about what all components are there inside the VFDs that you use in your daily practice. I'll be taking example of Ishikawa VFD over here, but all the VFDs have same components as far as the electronic circuitry is concerned. And I'll touch upon briefly upon how each component acts in providing the functionality of VFD that it does to us in the end. So I'll straight away start into what all goes inside your VFD, and this is completely I'll be showing to you on a presentation only, so that you get an idea next time you open up a VFD, like what all is there and what functionality each component is performing on this. So this is the overview or internal topology of your VFD. As you can see in here, like we have a lot of components. I'll start over. So this is the single line diagram or internal configuration of VFD that we have. At the input side, we have your rectifier circuit, and in this circuit we have diodes that we use inside the VFD. Just after your rectifier circuit, we have your DC choke. So this is there in some VFDs in certain ratings, and it is not compulsory to have DC choke, but if there is a DC choke, it ensures harmonic correction by the VFDs. Here also before diode we have MOVs. These MOVs are there to ensure the safety of the VFD. So you give your input supply, MOVs are the first line of protection against any surges. And then we have your rectifier circuit. So in rectifier circuitry we use diodes. After that we have DC choke. So DC choke is there purely for harmonic correction. And then we have your soft start circuit. So in this we have a contactor, and in parallel to that contactor there is a resistance. So why this circuit is there? This is to ensure that your capacitor, which is next in line, gets charged slowly. So whenever you will give a power supply to your VFD, the supply will flow through this resistance. So your capacitor will be slowly charged, and after a certain voltage level is reached, a certain DC voltage level is reached inside the capacitors, your conductor gets latched, and automatically thereafter the supply will flow through this circuitry only, and the resistance will be bypassed. After that we have capacitor, as I just told you. So capacitor is storing the energy as well as purifying the filtered DC that is coming from the rectifier circuitry. And thereafter we have braking circuitry. This is sometimes inbuilt inside the VFD, and then at times it is external to VFD as well. So this is there. This is purely a transistor which comes in effect after a certain rise in DC voltage of inside VFD. So whenever there is a regenerative braking or regeneration happening in the application itself, at that time a voltage level inside the VFD rises up, and to ensure the safety of a capacitor and the circuitry behind it, we connect an external resistance to these two terminals of the VFD. But when this resistance will get supply, and the complete will depend upon this braking transistor. So braking transistor will come into action only after a certain voltage level is reached. After this we have your IGBTs, and this is basically your inverter section. So after capacitor, this is important part to understand, because braking circuitry is sometimes inside the drive, and at times we are using it external as well. You use external choppers for this which are directly hooked onto DC bus of the VFD. So these IGBTs ensure your DC that we have right now with us gets converted into your AC supply or PWM basically. So these IGBTs, they switch in a pair, and they give us the output of PWM output, pulse width modulated output, which is used to run your motor. So this is how it is. So talking about components, we have like diodes here in rectifier section, then we have your DC choke, we have a resistance and a contactor inside VFD, we have capacitors inside VFD, we have various transistors, IGBTs inside the VFD. This is how your IGBT will typically look like. Above this circuitry we have PCBs, like we have power board, which is giving your DC power source to everything inside the inside the drive, like your control card is there. Control card basically has the brain or the processor of the VFD. Then we have terminal card. Terminal card is there, which on this card we connect your IOs, be it digital input, digital output, or analog input or output are connected on this card. And this is directly connected to control card, and control card is directly connected to your power card. And power card also gives supply to your fans, which are not there in this photograph. And then we have your VFD display. So these all components are there inside the VFD. And if you want to know more about what all separate circuitries function, how they function, what all other major components are there inside the VFD, stay subscribed to this channel. Please subscribe it and click the bell icon. I'll be sharing more videos with you. Thank you so much. And if you need me to make content on any specific topic, do drop in comments. Thank you so much.